are a lot of questions around how do we produce, how do we feed larvae, and the second part I will focus more on scientific data and the different data and progress found in literature. Now, regarding the black soldier fly, for those of you that don't know this black soldier fly, this is an insect that has come or originated from the Amazon, from the Andes, South American region. So this is a fly found in the tropics, and it has a very key characteristic because it's not, normally it doesn't really, it's not transmitting any diseases. So we've tried to produce this in a more industrial scale. This insect has this fly has a key potential because it can have an important protein contribution. Our company has established here in the Southeast Asia, because we have a perfect weather condition, 30 degrees all year round and around 70% relative humidity or moisture, and very similar to the tropics area in Colombia. I think you have very similar conditions, and so you could replicate the production of these insects. Also, as it has low production costs, there is a proximity to customers because it can apply very well to replace fish meals. Very much used in poultry industry here in Southeast Asia. It's around more than half of the industry. For example, this type of meals are also produced for fish farming, and so this is a strategic opportunity. There's also a protein sources gap in the region, as well as in Colombia, where you have to import, for example, soy paste, corn paste from other countries. Here in the Southeast Asia, for example, we don't produce enough soy paste, so there is a protein gap that is quite significant, which favors the development of this business. So insects are fundamentally sustainable because these are produced from residues that will be disposed of, so we can recycle these to feed these animals. So I'll briefly show what is a BSF industry, an insect industry. And so this is there are many videos of how we produce black soldier flies, but the operation is very, very simple. So we have the different pupae, or we have the full cycle of the pupae towards the fly, and this takes around a cycle of 21 days. So from the laying of eggs, we have the production of larvae, then the metamorphosis of this, all the way to flies, and so this cycle is full with this part. So one part of the larvae, or the larger amount of larvae, can also be treated, where we basically apply a mixture of waste received from different processed foods, vegetables as well, and also agro-industrial processed foods that are obviously regulated for a feeding level, and so these are reprocessed and then laid in different trays, and after 7 days we harvest these, we sanitize these, and these then are dried through different methods. And then we have, as an outcome, the protein meal, the BSF oil as well, and also the fresh larvae that can also be distributed and marketed. And then we also have the compost, the excretion of these larvae, which is a very, very good dry fertilizer. So this is basically a scheme, a diagram of how we can produce BSFs. There are many things to be developed, and a lot to be optimized as well. And each of these sections, they're are techniques, and there is also a technical team and other equipment, sorry, technical equipment, specific equipment that is undergoing investigation as well. This is our industry, and this is our facility. This is relatively new. We have an industrial park, a technological park here in Malaysia. Here is where we process the foods. Here is where we have the insect farming. And this is our production area. This is basically a warehouse that is weather controlled for this larvae. So everything is very well controlled so that nothing escapes. We are self-sustainable. We produce our own animals. So in 1 hectare, we have the whole cycle, as I just explained. So my role here and the challenges of the task I'm carrying out are the following. Well, I'm also in charge of the insect nutrition, and the first thing I observed when I arrived in March of last year was that there isn't really training about this. This is a very new industry. This is not a very well-developed industry regarding, for example, the nutritional requirements. So this information is very limited. And so I had to really bring a lot of poultry knowledge. And many of these concepts are not applicable. Some are for larvae specifically, but we still need to develop technical information regarding this insect nutrition. For example, if the enzymes work, if the probiotics work, if the additives work, we really need to develop all these technical information. The larvae eats once with, or we fed these larvae once with a liquid fermented feed. There are some complications, and this meal is given once, and it is fermented and in liquid state. So after 7 days, we harvest, and we really need to be careful about many factors so that the feed, the meal, is perfect for the development of larvae. So the alternative raw materials, as you can imagine, well, these larvae are very primitive animals. They're very resistant, and they can basically consume anything that is organic. Therefore, there is a multiple array of products that can serve them. We've tried around 20 different raw materials that other animals cannot consume. But of course, as these are alternative raw materials, we also need to develop and know very well what exactly are the components of these meals or of these raw materials and how we can combine them. So we need to really develop knowledge about this. And also we need to use NIRs and also channel each ingredient and therefore formulate in a much more precise manner cross feeds, low LCFFs or cross formulations, and the different costs and how we can combine different ingredients. So we can have a more stable diet and less variability in the results. And lastly, I just want to point this out as a curiosity point. Well, the digestion, that this is a very primitive animal and a very different to poultry and birds. So larvae have around or a maximum of 200 milligrams of weight per larvae. So this is a tube, and this larva basically recycles. It consumes its own excrete several times. So this is a bio-waste reactor, and we must really take this into account. This is a biological reactor that is basically doing this and has a very accelerated metabolism. In 7 days, it grows 1,000 times its own weight. So this metabolism is very, very much accelerated, and there is some gas exchanges, ammonia, CO2, because the evaporation of a meal of 70% water is finally very, very dry, only with 20% of a substrate. So this is a very, very intense and fast process. And then if we look at the digestive tract, we see that this is also a tube. Here we see the esophagus. This is a very, very subdeveloped esophagus. Therefore, they need to eat with very, very fine particles. And look, the pH in the midgut is 2. So it is very acidic and it can digest its meals several times. So it, or until it actually gains weight. So these are just some curious elements of information about the digestion of these animals. Now we have nutritional references that are being published. Here you have Carol Barragan Fonseca. She's a researcher that has actually dedicated her doctoral thesis. She's Colombian and she's done her doctoral thesis in the Netherlands, and her publications are a scientific reference for us, because these are very specific and thorough works that help us understand, for example, what is the level of carbohydrates that we need to add in the diet, what is the protein content that we need to add, and how we can combine these two different contents to produce more protein. So the good news is that you have a top researcher, for these topics, and she's publishing very interesting works regarding nutrition.
I'll
speak about what insects are for poultry, and I would like to emphasize something here and just remind you that insects and nature are insectivorous, meaning that if you look at a hen in nature, it's constantly looking for worms, for different type of worms and insects. So it's very important to know that birds are biologically suitable to digest this type of insect protein. So this is what we say, that the results that we are seeking at present are based on the fact that birds have the genetic imprint, that they are ready to digest this type of worms. So if we take a look at regulations, because there are many doubts around this, basically around the world, it is permitted to use insects for animals by respecting the regulations in every country in terms of how biosafety of this new products is assured. In Europe was one of the regions that should further develop. But last week, we had the happy news that it is totally permitted now for birds, for hens, and also other animals. So the industry will be able to use this. In other countries in Latin America, there are no regulations that forbid this. This food is considered healthy and it can be used for different species, as in Europe is used for swine and for birds. But the regulations must be considered in order to control quality and to be clear about how these products will be applied, how will the imports and exports will take place for these insects, as well as the farming of these animals or the creation of these animals. But generally speaking, there is a very good indication that it is being allowed now to be used for animals. If we take a look at scientific data published, as I was mentioning, this is quite a new industry. If we take a look at the first publications, the first poultry feed-related publications were done in 1973. The first publication was thought of as a past, as something. It was difficult to learn more about the natural history, but little by little, the application of these feed was progressed little by little. So this black soldier fly was developed and people fell in love because of the results being published. We have conducted a series of works. So for 70 years, since 1947 till 2017, in this graph, as you can see, only 137 works have been published. In 2018, 187, meaning that in 1 year, more works have been published than in 70 years of research. So this is something quite recent and novel regarding all the technical and scientific development of this industry. If we take a look at nutrients, what is it that we have in this feed? What makes it so special? So protein is basically around 50% of accounts for 50% of the composition of this product. So we compare to soy paste or beef or fish, the flour, and the pargamue, which is the palm-based flour. There are certain benefits. If we should make an analogy and produce a 100% ESF, meaning insect-based diet, we could fulfill all the requirements for broilers, for piglets, and layers. But if we take a look at the license requirements, some of these products do not fulfill them. So if we were to add a 100% insect-based diet, we should have to add lysine. And there are also some examples as to how the amino acid composition and protein take place and how they can be applied for broilers and layers. This diagram was something I did this week. I was formulating a meal for swine. And I know this is not the target or the audience for this, but I would like to highlight something very important I managed to conclude. So this diet was for a client in Europe by using 12% insect flour to replace dairy products and vegetable protein. And what we have here in gray is the contribution. This is what the insect meal has done in nutritional terms. So if we take a look at dry matter, 12% added or contributed to protein nutrients by 30%, 49% in fat requirements, lysine 27%, 33% in amino acids, and 22%, 15% arginine, and so forth. Calcium accounts for 58%. This meal has much calcium because the pulp of the skeleton is quite rich in calcium carbonate. So over half of the calcium requirement and 28% of phosphorus requirement for piglets was fulfilled just by using 12% insect meal, just replacing 1/3 of the protein of this meal. And this is just to mention some of the benefits of certain nutrients. This is just an example of how it can be used. So it's not only a matter of protein, it's also fats, amino acids, digestible amino acids, calcium, phosphorus. It's a very comprehensive and complete meal for different species. Here we have a compilation of the latest works. If you want, you can take a look at them later on for broiler chicken, for pigs and laying hens. We are using around 3% to 10%. This is what we can see in current literature. So if we use 10%, we will be replacing at least 1/4 of the protein in the diet for an insect-based protein, which is quite digestible and brings plenty of benefits. In another piece of work, the meta-analysis, 2000, 174 works were analyzed, and The majority of works showed 10%. Most of the work has been conducted in Europe, Africa as well, with Africa has many researchers as far as insects are concerned, so we have many works that have been used as a reference. So publications for 2019, but if we added 2019 and 2020, every month we have new publications around the subject, reinforcing the curiosity the academia has around this industry. And it has been concluded that up to 10% would be fine. Of course, there are some papers or pieces of work that state that by getting to know these products better and allowing the industry to further evolve, the quality can improve. The latest works have been done with a very, very good outcome. Here I have included something about insect oil. We can extract 10–20% of oil from the maggot, from the larvae. And some researchers from Italy, for example, replaced 50% and 100%. In this case, they used soy oil. And the result was a trend that shows an improvement in weight gain by replacing soy oil by 100%. And also the feed conversion ratio, there was a trend, an upward trend. You can notice here. But here in this, the table to the right, you can notice a significant improvement while replacing corn oil, coconut oil, BASF oil by 100%. So there's a clear indication that insect oil can be quite beneficial to use it in poultry specifically, and especially because it is rich in fatty acids, and chain fatty acids, and antimicrobial peptides. So the larvae are developed in nature to consume dead animals. And from the biological standpoint, it has been designed to consume this type of flies. So they are bacteriophages, meaning they have different mechanisms to kill bacteria, virus, fungi, everything present in hand droppings. This has been published recently. There's a very good literature review that has been published, and there are around 50 genes that can have antimicrobial effects. These are part of the effects that these type of new ingredient can pose. If we take a look at the digestive tract of insect larvae, we can see that there's a huge capacity to digest food or nutrients. That bacteria, where these larvae are developed, are a super dirty environment full of bacteria, so mechanisms need to be developed. And here in this work from 2018, researchers have mentioned some of the mechanism of the production of lysozymes, pepsin. Remember that in the intestine, there's a pH of 2, quite acidic. So bacteria need to be killed. So when understanding digestion, we need to understand how these larvae consume microorganisms and how they can be useful at a barn to clean, for instance, hand droppings. Here we have conducted a very simple test in our microbiology laboratory. We replicated E. coli, Salmonella, and Staphylococcus aureus, 3 important pathogens in poultry farming with bacterial growth inhibition, zone diameter. So it's a very simple test where we compare bleach, which is an antimicrobial agent, and a control treatment with water. So of course, bleach had a strong effect in order to inhibit this bacteria. And the protein, the dry larvae, and the oil had an intermediate effect, very similar to the positive control, but a very powerful disinfectant feature. And this is what we have conducted in our laboratory. Just to give an example, there are many pieces of work in literature that apply this. It was noticed that there was a very positive effect as to reducing salmonella populations in poultry farming. This test has been published last year in a group from in Holland, where they were interested, or I mean, it's very interesting because it was used as a live larvae. So there were 2 groups of layer hens. One used a commercial meal, and the other one used a diet that is soy-free, that does not depend on the import of soil. We know that in Europe, they are trying to avoid importing soy. So in this group B, they noticed that there were 8 replicates of 22 hens in each group. 275 grams were administered for every replicative live larva. So from 11:30 to 5:30 p.m. in 6 hours, they dispensed this larvae very slowly to the different replicates in the group. And it was observed that, not counting on the larvae, the intake of this feed was significantly lower because hens were feeding or looking for, they were fighting over the worms. And the conversion was also significant. Less food was, or less feed was consumed. It was also observed that there was a general well-being of birds. So the B group, the blue line, laying hens on the floor, and this indicates that there's something more to this, but beyond the nutrition, there's well-being. Hens knew that the larvae would be, or the worms would be ready, and they would go to the floor just to feed themselves. What was also observed in this piece of work was that the score of the feathers, the well-being score, where hen that are stressed start fighting with each other. So there was a trend for group B to have more stressed birds. And at the end of the test, this was inverted. So it was concluded with this piece of work that hen, when they have something to explore and it's something natural to their behavior, they were happier. They had a sense of well-being and less stress, and they would stop fighting each other.
In very recent work of this year, we also carried out a comparison of the substitution, or one of the diets with 15% soybean cake, and we replaced it for an inclusion of BSF, industrial BSF, of 15%, and also a BSF that was produced at a more non-industrial scale. So what we've observed here is that there was a difference in body weight, feed intake, and the different diets. This was not a very significant difference. However, we did observe a significant difference in the egg weight for this group right here. And also for the egg mass, we saw a significant difference, and we also saw a trend of a better FCR, a better conversion for this group. So the message we want to convey here is that there are, well, we can produce BSFs with waste from your own kitchen, but the industrial level that the industry needs for this, we really need to enrich and keep protein and amino acid levels at a very, very high level. So not all BSF products are the same. And what we've seen in the literature published is that there are many, many works that used substrates, for example, restaurant waste, or where diets are not really well formulated. And so we see that there isn't real significant difference in weight, and therefore that won't create a positive impact in our industry. Now, I want to talk a bit about special uses. Well, in the near future, there's lots of people that are working also with BSF to treat the different meals. This is a project of what we will do with this chicken manure and basically this, or the hen droppings. And so we know that these larvae are very much prepared to digest hen droppings or chicken manure, and therefore in 7 days, around 7 days, we can dry this hen dropping and use a very good fertilizer that is sold at a very high price, that has an important biological load and important components that are very important, for example, for plant production. And this is the part that is not very much explored, but from the pharmaceutical industry, we can extract, for example, the biomass and other biomolecules that we still need to explore and would need to analyze more on what are their effects specifically on the excrete of larvae. And also, we can produce almost at zero cost a product that is rich in proteins and that can be used as microbiomes. There are many people in the industry that are working with this larvae to produce fats and oils for biodiesel by recycling ingredients and therefore producing biodiesel at a very sustainable manner. And with this, I'd like to close and round up my talk. I think I am right on time, and I would also like to share just some ideas, some areas in which I believe we still need to develop and improve the bioconversion. Well, here we have a conversion in some dry meals of 1.6, 1.7. So without any development, we're almost reaching a conversion similar to the ones of birds. So there's still a lot to learn about the formulas, about the different raw materials to be able to produce food with larvae. We also need to understand much more about mass production. We still need to develop this. We've done, just to illustrate, a small calculation. If we would wish to replace in 10%, just 10%, the fish meals of the world, we would need to replicate this facility that I've just showed you in this photograph for around 400 times. So we still need to improve this industry. This industry is just starting, and we need to do this so that we can also drive costs down. Now, regarding genetics, the genetic improvement is still very subdeveloped, and we have a great potential to improve genetically, and this can also lead to a higher life performance and therefore improve also the bioconversion of the waste. And regarding nutrition, as I've mentioned before, well, we still have a lot to learn. We are currently doing a very, very robust project with Ionphonic to know and learn about the requirements of biomass for these larvae, and also learn how we can apply this with new technologies in our production. And lastly, now health. This is not very well known yet. These are organisms that are very resistant, and they live within our societies. They're very resistant to diseases. They don't die due to contact or exposure to medicines, for example. But there's always the question around, well, what is the health of these larvae like? So now with this, I'd like to conclude. I'd like to just thank you and also provide my contact information and invite you to visit our website, nutritiontechnologies.com, and also our social media. We are growing at a very fast rate, and we are also hiring and recruiting new people and new roles from the poultry industry that would also like to work and know a lot more about this fantastic industry. So I'd like to please invite you to visit us. So thank you very much, and I'll await for the questions from the attendees. Mauricio, I'll give you the floor now. Thank you very much, Dr. Rafael. So before starting the next presentation, which will be shared by Dr. Christoph Casaban, I will give the floor to Alejandro, our technical director for this session and the production of this event, and he will briefly explain how to use the interpreting module to be able to hear this conference interpreted into Spanish. Well, good morning, everyone. To those of you who weren't at the beginning of this meeting, I'd like to just briefly explain how you can activate the interpreting module. In the lower part of your Zoom window, you will see a world icon, and if you click on it, you can select the language of your preference. If you're a Spanish speaker, please select Spanish, so you will be able to hear the interpreting of this conference from English to Spanish. Also, if you are joining us from your mobile phone, you will see this screen, and please click on the three-dotted icon at the lower right-hand corner of your screen. And then you will select language interpretation, and you will be able to also select Spanish. So, while Cesar shares his screen and helps us with the following slide, we'd just like to remind you that we have the chat available as well for your questions to be shared there. We are reaching almost 60 attendees, and we have participation from Central America, South America, and Europe. Cesar? All right, I think we have a small technical inconvenience. So our next presenter is Dr. Christoph Casaban. Now, just taking into account this very, very pleasant last news that we have regarding this Newcastle disease, well, Colombia is now a certified free country or a country free of this disease, and we thought it was very pertinent for the steering committee and the scientific committee of AMEVEA to have a speaker, a well-renowned speaker, to talk to us about these control mechanisms, and that can help us to reinforce these ideas and controls, and most importantly, how we can use the different tools available to be able to maintain our current status. So next, we will have Dr. Christoph Casaban with us. Dr. Christoph, could you please share your screen?
Okay, very good morning, everybody. Greetings from France. It's my pleasure to be with you today. I would like first to thank AMEVEA for inviting me to give a talk to this important conference today. I would like also to thank Dr. Rafael for his previous talk, which was very interesting, and I learned a lot from it. Sorry for not being able to speak Spanish, so I'd like to thank the translators in advance for their efforts in translating into Spanish. So as mentioned by Dr. Maurizio, I'd like to start my talk by a very recent news, and actually a good news, considering this information that was released on the internet, that ICA recently, as you can see, it was in April of this year, ICA declared that Colombia is now free of Newcastle disease. So this was a letter that has been sent to the World Animal Health Organization, the OIE, in order to state this very important milestone towards this international organization, as well as to be shared to the rest of the world. So definitely, I'd like to congratulate you first for this achievement, because actually we know that it's a quite long journey, and it needs the cooperation, and I would say the work of many stakeholders, not only the state, but also the production companies, the veterinarians, the laboratories. Is definitely a teamwork to be able to reach that point. Indeed, it includes a quite extensive amount of tests and analysis, because it needs surveillance, regular monitoring, diagnosis, and ultimately reporting. So you can understand that transparency, communication, and trust among all stakeholders is absolutely key in order to reach that point where indeed we can ultimately consider that the country now is free of reportable Newcastle disease, namely velogenic Newcastle disease. We still have to remain cautious, since the risk is never completely gone away. So we must keep on running very regularly, constant watch in our commercial flocks as well as in non-commercial flocks, since it's very clear that, for instance, backyard flocks, small scale hobby flocks, and needless to talk about the migratory birds, can be a reservoir of Newcastle disease. So that's why this is not the end of the story. I would say it's rather the beginning of a new story for Colombia. If we have a look a little bit more broadly, it's still important to mention that Colombia, unfortunately, is still surrounded by some countries where velogenic ND, so the pathogenic form of Newcastle disease, is still quite present, quite endemic. I'd like to mention here some recent confirmation from Venezuela as well as from Peru. So in the, let's say, northeast as well as in the south, where velogenic Newcastle is still there. On the opposite, in Brazil, as you know, the country is Newcastle free for a long time now. So the situation for Colombia is good, but again, we should not relax. We should not stop doing all efforts necessary to run some surveillance, some surveys, in order to keep on watching and detecting any possible new case of the disease. So, in fact, the risk breakdown can be done as follows. Actually, whatever the status of the country is, there is still a risk of uncontrolled virus circulation. As far as Colombia is concerned today, as an ND-free country, and the same is true for Brazil, for United States, for France, my country, there is still a risk of facing the uncontrolled circulation of lantogenic vaccine strains. Because we are still using Lasota vaccine, H1N1 vaccine in breeders, in layers, in turkeys, in different types of birds, sometimes still in broilers. So these strains although they are supposed to be attenuated, so to be somehow safe, they still possess some residual pathogenicity. And we know that if we keep them circulating for quite some time, it may hit the houses, the buildings in an uncontrolled situation, and it may severely hit your flocks in terms of secondary, opportunistic infection by E. coli and ending up as a air circulitis, so slaughter issue. So we must keep on watching this type of circulation. On the other hand, of course, if we are in a Newcastle endemic country like Peru, like Venezuela, then we have definitely to prevent the circulation directly of pathogenic strains of Newcastle disease, the so-called velogenic strains. To do so, biosecurity is a must, but we also have to apply vaccination. And since the beginning of the 1960s, there have been a continuous improvement in vaccine technology as well as in vaccination programs. Namely, in the very beginning of the, well-organized poultry industry, we were dealing mostly with live vaccine. So H1N1 live vaccine, Lasota live vaccine. Back to the 80s, and especially to deal with higher challenge of Newcastle disease, it became obvious that by combining a killed vaccine at early age on top of live vaccination program, we could get a stronger protection against a stronger challenge. So that's why this became a kind of routine vaccination program in many endemic countries around the world, not only in Central and Latin and South America, but also in Middle East, in Southeast Asia. And in the, let's say, for about the last 15 years, there has been a new shift towards a further improvement in vaccination program, thanks to the appearance of the vector vaccine technology. In other words, the recombinant vaccines. So what it is? Here, you've got the I will try to put my pointer. Yeah. So here you've got the Newcastle disease virus, and the idea is to consider that actually what we need is only the external part of this virus. So the part that is going to be recognized by the immune system to produce protection, to produce immunity. And indeed, the most important part of Newcastle disease virus is the fusion protein. So that's why the acronym F, which is on the surface. So the idea of the recombinant technology is to consider that, okay, let's take the gene that is responsible for the production of this protein, and let's take another virus, which is a very safe virus, and namely it's a herpes virus of turkeys. That's why the acronym HVT, that is going to be used as a vector, if you like, a vehicle. It's like a taxi, okay? You are the gene and you take a taxi. So HVT is like this, is the vehicle of the gene. So this foreign gene has to be inserted into a specific location, not at random, but in a very specific location, to be stable, so that ultimately your herpes virus of turkey will also express on its surface the antigen of Newcastle disease virus. By doing so, we are getting ultimately a Marek vaccine, because you know HVT is a Marek vaccine strain. So in ampules like this that are kept frozen in these liquid nitrogen tanks to be reconstituted with a very regular Marek diluent. in the hatchery. But the difference is that this Marek vaccine also vaccinates your chickens against Newcastle disease thanks to this F protein that is inserted into it. The good news is that nowadays there are more and more vector vaccines for Newcastle disease that are marketed by more and more vaccine companies or animal health companies. So it's good for you as a producers, as a veterinarians, because you have a wider choice. It's not depending only on one company under a kind of monopolistic situation. However, they are not the same. I mean, even though we are always using the acronym or HVTF for recombinant HVT vector that is expressing the F protein of Newcastle disease, here in this diagram, I'm showing you the three main existing vector vaccines for Newcastle that are present today on the market. And indeed, as you can see from this schematic, the three constructs are quite different. Here, this gray line is the genome of the Marek virus, the genome of HVT. And here, this blue box is the insertion of the fusion gene of Newcastle disease. So you can immediately notice that depending on the vaccine manufacturer, the insertion of the gene is not done in the same place. Here it's in between two genes. Here it's inside the gene, and here it's also inside the gene. In addition, we use a promoter, which is a small additional sequence of nucleotides that is there in order to attract the polymerase in order to generate fast and high amount of proteins on the surface. So the nature of this promoter also varies according to the animal health company. So you see, even though it's the same technology, but indeed vector vaccines are different because they are made of different constructions. Of course, all of this has to be confirmed by checking these vaccines in chickens in order to see whether this variation in construction has an impact into the features of the product, but it does. So if you take home message at this stage of my presentation, we have now access to a brilliant breakthrough vaccine technology, which is using the vector HVT technology, expressing the F protein. Why is it a breakthrough technology? Because actually it's enabling several improvements compared to the conventional technology. First of all, it's a very safe option. It's a very safe vaccine. We know that HVT is an extremely safe virus. And because it's quite efficacious, it enables you to apply less live vaccine boosts in the field. So that's very interesting. It makes your vaccination program simpler, makes your life easier, and it's less stress to the trachea of the birds, again, because these live vaccines may be harmful at the end towards the upper respiratory system of the chickens. Second important asset, we are getting a consistent and constant immunogenicity. Remember, this is Marek technology, meaning that it's presented in cell-associated form. It simply means that it's capable to induce immunity, even though your day-old chicks are provided with maternally derived antibody. So this vaccine technology, contrary to the live or inactivated vaccines, are capable to induce immunity despite the chicks are provided with maternal immunity. In addition, because it's a herpes virus, it stays in the body of the chicken forever until its end of economic production, regardless you are dealing with broilers or commercial layers or breeders or GPs. It's HVTs, it stays forever. The vaccination itself is done in a much advanced, much better way, just because it has to be done in the hatchery, either by in ovo route or at hatch by subcutaneous route. And we know that by doing so, we can get a much higher vaccination success, vaccination quality, as compared to vaccination in the field. Finally, as I mentioned before, and there have been already plenty of published evidences of that, these vaccines are indeed capable to provide a superior efficacy compared to the conventional vaccination approach, in such a way that they are providing superior protection as well as a stronger reduction of virus shedding. So that's obviously a few very, very interesting points. The question, and that's going to be the topic of the rest of my talk today, is there still room for further improvements based on that? Yes, there is, of course, there is. So let's step back a little bit and just realize and agree among each of us that the poultry industry of today is extremely successful, is extremely efficient, because in most of the countries, in most of the I would say in the countries where the poultry industry is well developed, and that's the case of Colombia, obviously, we are dealing with larger and larger farms, bigger and bigger complexes. In such a way, we can produce high quantity of protein, either meat or table eggs, in an affordable price for the population. So to ensure food security and food safety. So it's quite efficient, it's very good. And it's a common trend everywhere around the world. The point is that, is there a kind of Achilles heel in this system? I just took the example of the US, where here in the northeast, you've got what is called the Delmarva Peninsula, which is encompassing Delaware, Maryland, and Virginia. And you can see in this small peninsula, you've got the distance here. Look, all of these dots are not one farm or one house, but they are several houses. And the darker, the more houses. So you see, that's probably the area of the most densely populated poultry population around the world. And Colombia also is somehow dealing with the same situation, if I may. I was pleased to find in a very recent publication from Dr. Mesa, it was about coccidiosis, this scheme of the Colombian poultry industry, and showing very precisely that basically you've got 2/3 of the production, which is concentrated in 4 provinces. And within these 4 provinces, Santander definitely is incorporating the largest amounts of poultry farms. So indeed, in Colombia, like in US, like in France, like in many, many countries, there are indeed some areas where poultry farming, poultry density is very high. So that's good, but in terms of Achilles heel, the weakness, if I may, is about the spread of viruses. If you consider we are in Santander area, let's say, whatever area, where you've got many, many complexes that are next to each other like this, and even in one single complex, you are getting plenty of buildings like that. Whatever type of virus is penetrating into your complex, so it could be a lantogenic strain today because Colombia is Newcastle free, but it can also be a velogenic strain in an endemic country. So if this complex is getting hit by this virus in one single building, what would happen in case we are not able to strongly control the spread of this virus? If we don't control it, then this building will act as a kind of reactor, will multiply this virus. And again, it could be a lantogenic Lasota strain, but it will spread to a larger amount to the neighboring houses, and so on and so forth, progressively into the whole complex, and ultimately spread into the environment towards the next complexity, so towards your neighbors. So this remains a risk. And again, the fact that the modern poultry industry is nowadays more and more condensed in restricted areas, this creates a higher risk towards this introduction and further spread of viruses. So what can be done? Let's look at the lessons that we've learned from the current COVID-19 pandemic. We know that if we don't do anything, one infected human may be able, let's say, to infect 2 humans that will be able to infect 2 more humans, and so on and so forth. So you can see the exponential framework of the speed and the rate of contamination. What is interesting is if we manage to break this transmission chain through social distance, social barriers, wearing masks, getting vaccinated, and so on and so on, if we're able to break this chain, it's interesting, because ultimately the amount of people that are going to be infected is getting much, much less. And again, it's going exponentially. So that's interesting. Can we play on that level to break this transmission? So to do so, we have to use a model that the epidemiologists know quite well. It's so-called the SIR model. S stands for susceptible, I stands for infectious, R stands for recovered. So let's try to see how we can apply it practically in the context of the poultry industry. You can imagine that in the beginning, especially if a bird is not vaccinated or improperly vaccinated, it's susceptible. In case of a contact with a virus, this virus will replicate, and so the bird will enter into a stage where it will be regarded as infectious. So it will become dangerous towards the other birds. So this is where the spread may start to happen. And of course, at the level of this bird, the final outcome is either the death or the recovery. By vaccinating, we are trying to minimize this succession of events. By reducing the susceptibility of the bird, in other words, making the bird more resistant, by trying to prevent to move to the infectious risk, and obviously to prevent the death. But all of this is valid at individual level. In the poultry industry, we don't think at individual level, we think at flock level. So at flock level now, if we consider a disease where an infectious bird can infect 2 more birds, and these 2 birds can infect 2 more birds, can we find a vaccine? And especially, can we assess how strongly a vaccine would be able, for instance, to break this chain by half? That would be already a quite nice outcome. And can we go even to less than one chicken? In other words, in case by any chance the chicken is getting infected, but the protection will be so strong that actually it will not be able to infect more than one other chicken. So does such a vaccine exist that will eventually stop the transmission of the disease? So I'd like to share with you the results of a study that has been recently published in the peer-reviewed journal. This is an open access paper, so you can freely access to it. And I'm going to show you now the main outcomes of this study. So the aim was to be in a broiler situation that would be reared for 42 days. So this was the hypothesis at the beginning. And the aim was to quantify the transmission of velogenic Newcastle disease virus. So we put ourselves in a worst case scenario. And of course, the question would be, can we reduce this transmission ability? So to do so, sorry, I have to enter into a little bit of mathematics here. We have to calculate what is called the reproduction ratio. You know, this famous R value. And here, for instance, it's superior than 1, it's actually 2. So this R, which is basically the average number of secondary infections caused by a single infected bird, is calculated using two criteria, two figures. One is the transmission coefficient itself. So how many infections can we detect per bird per day? And it has to be multiplied by the number of days where a given bird is actually infectious, okay? So to which extent an infected bird is able to infect other birds and for how long? So this combination, this product of two figures will ultimately give us the R value. So quickly, we used commercial broilers and we vaccinated some of them using this famous RHVTF vaccine, and we used the Cedar vaccine to do this experiment. And we decided to apply a velogenic Newcastle challenge to half of them, so to 20 birds at 42 days. The other half, so the other 20 vaccinated birds, were kept apart, and they were brought in contact to the challenge ones 8 hours later. This is to mimic the field situation. Just imagine we are in a given house where all the birds are vaccinated, so that's the case here, but some of them, unfortunately, are being hit by Newcastle virus. So here, the idea is to measure how would behave the other birds that are also vaccinated, but in contact of these challenge birds. Of course, this has to be compared to pure controls. In other words, birds that are not vaccinated and where some of them have been challenged and some others brought in contact 8 hours later. So this is just another way to represent the same thing. Vaccinated birds, some of them were directly inoculated by the pathogenic strain, whereas the other ones were brought 8 hours later commingled. And the same in the control birds, non-vaccinated, half of them were challenged, half of them kept apart, and they were brought together 8 hours later. So the objectives in this study are the following. Of course, is to confirm to what extent did the vaccine increase the resistance to the infection. Secondly, to what extent did the vaccine reduce the shedding towards the contact? So these are criteria that are commonly checked in every single experiment including in different publications that have been released in the scientific literature. But what is new is this last step, which is to what extent did the vaccine increase the resistance to the horizontal spread? In other words, to which extent did the vaccine reduce the likelihood of this horizontal spread within the building, within the same group of chickens? So an important point to mention is that after challenge, we checked the velogenic virus recovery by cloacal route and by oronasal route, as commonly done, but we did it on a daily basis for 14 days duration, which is quite uncommon because usually it's done twice, 3 times at most. But this time we did it daily, and each and every single bird to have a very careful and deep assessment of the outcome of the challenge. And so to manage to classify the birds according to this SIR model, we had to calculate this beta factor as well as the infectious period factor. So we used a generalized linear model for the beta factor and a parametric survival analysis for the infectious duration calculation. And again, the R value was beta multiplied by T infectious. So let's have a look at the results now. First, survival after challenge. As expected, you see here on top, either the green or the blue signs, 100% survival after challenge. These are the vaccinated birds. The control birds died very quickly. They start dying at 6 days, 7 days after challenge. So these are the directly inoculated control birds. And the control birds put in contact, they started dying with 3 days delay. So the challenge model was validated since we were able to kill all of the controls, and also the controls were able to spread the challenge virus to the contact ones that were also eventually showing 100% mortality. If we look at the shedding now, these are first directly inoculated birds. Perhaps let's start by the controls here on the right-hand side, the red ones, non-vaccinated, challenged. Each dot represents one chicken, okay? Here, these are the oronasal swabs on the top. Here on the bottom, the cloacal swab. So you can see that soon after challenge, let's say 1 day for oronasal, 3 days for cloacal swabs, all the birds started shedding the challenge virus, and even to a high extent, because there is a quantification of this shedding amount, until they die. On the opposite, in the vaccinated group, most of them did not shed any virus, or to a very low amount, and only few birds that are here in the top were showing some shedding of this challenge virus, which is again confirming what we've seen before in other experiments. I remind you that the challenge virus was applied by oculonasal route, so it is quite common when we swab the bird in the same place still to be able to detect some challenge virus. On the other hand, in the cloacal swabs that are somehow showing to which extent the challenge virus is able to disseminate within the body of a vaccinated bird, this shedding was extremely reduced. So I would say, as expected until now, the shedding was significantly reduced in the vaccinated birds. But what's interesting in this experiment was the behavior in the contact birds. So if we start by the controls, again, you remember they started dying a few days after the directly inoculated ones because they are controls, they are not vaccinated. So they also picked up the challenge virus. They started replicating it extensively and ultimately they died. On the opposite, the vaccinated chickens that were brought in contact to vaccinated and challenged chickens, they showed an extremely reduced amount of virus replication and of virus shedding. So if we try to put it now in figures, and this is where we got the help of Utrecht University scientists who are really experts into this approach. First of all, we are able to show a significant difference, you see here the p-value, of the infectious period in the contacts when we compared vaccinated birds to unvaccinated birds. Because there is a strong reduction of this infectious period. And of course, the outcome is different. Here, the contacts are surviving, whereas here, the contacts are ultimately dying. In terms of transmission coefficient, so it's intrinsically how much each individual is able to infect other birds on a given time point. And here again, there was a very significant difference between the two groups. So this beta figure is very interesting because basically here we can say that if you vaccinate, you reduce by 3 times, almost 3 times, it's 2.8. So let's say 3 times the transmission capacity of your birds. So it's important because for sanitary officers, for government officers, for sanitary veterinarians, that's very important. In case, unfortunately, you have to depopulate a flock, in case we detect velogenic nuclear cell infection and you need to stamp it out. Because of this reduced beta transmission coefficient, you have basically 3 times more time to intervene for your biosecurity measures, for your massive slaughter activity. It allows more time to intervene. Finally, to calculate this famous R figure, which is just a multiplication of T infectious by beta, we end up into an R which is significantly below 1 in the vaccinated birds, whereas in unvaccinated, it was 3.2. So basically, what it's showing to you is that a velogenic nuclear cell virus is provided with an R of 3.2. So in other words, a susceptible bird that is going to be infected by such a velogenic nuclear cell is able to infect statistically 3.2 new birds, whereas a bird that is vaccinated with this type of vaccine, or HVTF, or at least the one that was tested in this experiment, could not spread the infection towards another bird because this R value is below 1. So I would say that's the main good news of this work. And so if we calculate just one criterion further, which is the probability that a virus introduction into a flock will result in an outbreak. So this probability is calculated according to this formula. And because in vaccinates, the R figure is below 1, then this probability is becoming negative, right? Whereas if you don't vaccinate or if you don't properly vaccinate, this probability is almost 70%. So it simply means that most virus introductions in vaccinated birds will not result in an outbreak because of this R, which is below 1, and so this probability which becomes below 0. So if we come back to this initial scheme, if we consider a complex that is fully vaccinated and that by chance or unfortunately one of them for some reasons is being hit by either a lantogenic paramyxovirus type 1 vaccine strain or a velogenic Newcastle vaccine strain, and that it's spreading this virus to the neighboring houses, what would happen? It will not propagate further from house to house, just because of the data and the figures I've shown before. And ultimately, you will also prevent the further spread into the environment to the neighboring farms, to the neighboring complexes. So that's obviously very critical, either in dense areas or in areas with multiple age farming systems or broilers, layers, breeders in the same place. And thanks to Dr. Leonardo Alvarado, I'm able to share with you these very recent data coming from Colombia that are just illustrating in simple way what I just showed before. By running some IDEX ELISA testing at slaughter in broilers, in given broiler flocks, this is the same company where our teams managed to monitor the flocks, as you can see, regularly from 2016 up till now. And in the very beginning, when this company was using, let's say, a previous Newcastle program, the Newcastle titers were a little bit erratic. Some of them were pretty low. Some others were, I would say, expected. And some others were extremely high. So which is showing very clearly that there is a lack of control, I would say, of stabilization of the circulation of Newcastle disease virus. And by applying a vaccination program based on this new technology vaccine, the vector vaccine technology, we were able, step by step, to contribute towards this stabilization, cooling down of the pressure of these circulating viruses within complexes, within flocks, at least in this company, in the area where it is operating. And this is an illustration that helped ICA to state that ultimately Colombia is now Newcastle free, just because of this lack of detection of uncontrolled virus circulation in the country. So, final take-home messages from this demonstration. Actually, the combination of fewer outbreaks and in the same time, smaller outbreaks, I mean, with less consequences, enables to get ultimately much less between flock as well as between farm transmission, until ultimately we can claim that the transmission would be stopped after a while, thanks to this extremely strong control of the horizontal spreading. Just a tentative of explanation for this, it has been already well demonstrated and it has been published that this technology vaccine is able to stimulate all different types of immune response. That's very interesting, since it's able to strongly stimulate the humoral immune response, so the antibody production, but also the mucosal immune response and the cellular immune response. So it seems that thanks to this extremely strong, I would say, immunity activation, we can get as a result this extremely interesting protection level. So the consequence of this, in free countries like Colombia today, like it is the case for Brazil, for US, for Western Europe, by applying vector munendi, or let's say this vector HVT technology, thanks to this ability to break the transmission chain, we are indeed able to successfully prevent new outbreaks, or whenever a new outbreak happens, the further spread of the disease. So that's, I would say, pretty good news. In endemic countries, it's also quite interesting because due to the fact that the risk is higher, usually we add a few live vaccines on top of HVT-F vaccine. So whatever is going to further improve this reduction of the transmission of the virogenic strain. So you see, regardless of the situation or the status of the country, whether you are in a free country or in an endemic country, this transmission, this ability to break the transmission chain is quite interesting, quite profitable, I would say, for the producer and for the chicken eventually. So that's the end of my talk. This is my contact details should you need any further information. Again, I'd like to thank Amevea for inviting me to this poultry day. I'd like to renew my thanks to the translators, and I thank you for your attention. Gracias. Merci.
Dr. Christophe, muchas gracias por la presentación. Rafael,
Dr. Christophe, thank you very much for your presentation, and Dr. Rafael, likewise, thank you very much for your presentation.
Entonces, pues, dando continuación.
All right, so now we'd like to continue with today's program.
Vamos a iniciar con la sesión de
and we will start with the Q&A session. This dialogue we'd like to have now. So the first question that I have is for Dr. Rafael Hermes. I think that you covered this in your presentation. Can you please, what are the levels of feeding, or what are the levels that are recommended for laying hens, breeders? Well, as an initial recommendation, we're talking about, well, as there is quite a big range of variability in terms of levels, it's very difficult to say exactly what would be the level of this. So the recommendation we do is to replace a fourth, meaning 25% of the protein source by the insect meal source. So for laying hens, it would be around 5% initially. And for piglets, for example, it's about 12% what we've used. And we have just finished a test with shrimp where we replaced a 6.6%. So it's around 5 to 10%. Those, I would say, are where we've seen the greatest benefits for laying hens. This is very, very safe, and it has multiple benefits for both broilers and hens if done between or up to 5%. Now, complementing this question, what is the estimate that you have in production costs when including insect meal? Yes, well, up to now, as I presented in my presentation, the industry is just in development. So our production costs, as we don't really have scales, are very, very high for the moment. So it's very difficult to compete with, for example, soy paste. So for laying hens and both broilers, the production costs would increase. And this will also depend on the country as well. Countries such as Colombia or Mexico. I actually was talking today with a colleague from Mexico where we import soy paste. They import soy paste a lot. Well, that will be very beneficial for them. But up to today, our price is established, and like fish flour is around $1,700 by ton. or $1,800 by ton. So in the market of the Southeast Asia, these are figures for the Southeast Asian market, because our costs, production costs, as I just mentioned, have not been lowered. So when this is increased, as I said before, we could use the 5% in replacement of soy paste, but this really depends on each producer. Yes, and I just like to mention that we see that each time it's actually easier to reach these market, of course, because soy is also increasing its price. Europe will be able to use, for example, meat flours or meat meals as poultry and the pork industry, and these markets that were consuming these type of products are not going to so much, and therefore there will be a gap. And if specifically we convey a message of sustainability, and therefore you can, for example, sell eggs or poultry meat a bit more expensive, as we have more sustainable methods within the markets. Thank you.
Voy a tratar de unir dos preguntas en una sola.
Dr. Casaban, I'm going to try to join or put two questions together. In your presentation, you were focused on broiler hen. What strategy applies for breeder and layer or laying hens? And regarding the use of recombinant vaccine with maternal antibodies?
Okay, thank you for this question. Indeed, you're right. This experiment has been done in broilers only and at 42 days of age. So we should repeat it in other types of birds and in other ages. But as you can imagine, this is going to take some time, and also for welfare issues is not very easy to be accepted. On the other hand, we've already demonstrated in controlled facilities that commercial layers that got only this HVT-F vaccine at hatch were fully protected against velogenic genotype 7 Newcastle strain at 72 weeks of age. 72. So again, this is confirming that the vector herpes virus keeps on staying in the bird and replicating and boosting the immunity constantly. And whenever there is a stress, there is a new boost of immunity. So actually, it's good for the bird. And we are quite confident that the same reduction of transmission would happen in these long-living birds, as you said, commercial layers or breeders, thanks to this long-lasting, very high level of clinical protection against disease, mortality, clinical signs, and shedding. So we are quite confident, even though I agree we did not run the same type of experiments in these other types of birds and in older ages.
Dr. Christophe,
Dr. Christophe, the second part is about your appreciation about the use of recombinant vaccine in the presence of maternal antibodies.
Yes, sorry, I missed that part. So that's exactly the point of using a Marek type vector like HVT, because it's presented as a cell-associated form. That's why we have to keep it in these liquid nitrogen tanks, just to keep the cells alive. And by this way, we are indeed capable to stimulate an immune response, an onset of immunity, in presence of maternal immunity to Marek and to Newcastle. So that's a major improvement, especially in endemic countries, where the breeders are usually hyper-immunized. So the day-old chicks are provided with a quite high amount of maternal immunity at hatch. And this may prevent the proper job of the conventional vaccines like inactivated or live vaccines. But this vector technology, again, Marek type, cell-associated, is the way to trigger immune response in the presence of maternal immunity. So that's why it's so attractive.
Muchas gracias por la respuesta. Doctor Rafael.
Thank you very much for your answer. Dr. Rafael, you showed a slide where you show that insect milk covers the protein requirements and amino acids as well. However, what will be the downside or the side effects? What adverse effect could we expect while including insect in birds' nutrition? It wouldn't be a side effect, but just being careful, depending on the type of product, how it is produced, what the phase of the larvae is, because it have more or less chitin, which is the cover insects have. So it could have an improvement or an effect of improving immunity, but is an anti-nutritional factor because birds are not able to digest it. So it is very important to consider the amount of the content of the substance and to take the raw protein. So we need to take this into account. Not all raw protein is true protein because kind of is a carbohydrate that is digestible but also contains nitrogen. So we have to be really very careful and have technical guidance as to how to do this in order to extract the chitin. So this is the adverse effect. If we fail to do this right, performance may lower. That's the only type of effect that could be adverse. Okay, thank you very much. Dr. Christophe, what will be the best way of monitoring a vaccination plan, HI or ELISA? And in the case of ELISA, what kind of kit should we use, considering that in Colombia, recombinant vaccines are used in some cases, all oil recombinant in some other cases, and in other cases, recombinant oil and live vaccine are used.
Okay, so indeed, when we use this type of vaccine, we have several ways for monitoring it. So first of all, we can have a quick check of the vaccination quality in the hatchery by running some audits in the hatchery using some blue dyes, these type of things, just to make sure that the chicks or the eggs are properly injected. A little bit later on in age, we can sample some spleens, let's say at 28 days of age, approximately. That's our recommendation, 28 to 35 days of age. Collect the spleens, and we are able to detect in the lab the presence of the F inserts in these spleens, just to show that indeed the virus is there and is replicating. Now, I guess the question refers rather to serology tests and kits. So indeed, this type of vaccine will induce immunity. However, the way to monitor this immunity may vary. That's why there are some specific kits that needed to be developed. And today you've got IDVET as a company, but also BioCheck, which developed specific kits that are able to detect the antibody response, which is elicited by these HVTF vaccines. Because what we have observed is when using the regular BioCheck or regular IDVET, regular IDEX, regular Symbiotics kits, by using only this vector vaccine, the antibody detection is rather low. So it's good to show the breaking down of the lantogenic strain circulation, but in order to make sure that the birds are indeed immune, we need to complement this with another type of kit. So either IDVET or BioCheck F that will specifically look for these antibodies that are elicited by the vector vaccine. Now, if your program includes different types of technology vaccines, namely live, killed, then any type of kit is suitable, I would say, because it's going to detect the antibody that are elicited by this type of vaccines.
Muchas gracias. Dr. Rafael.
Thank you very much, Dr. Rafael. You referred to the use of larvae or insects for the treatment of hen drop-ins or mature. So could you further explain what type of insects you use and what is the application model and in what stage do you use larvae or adults? I think this is an application that still is being developed in I+D. We do not use manure here because our approach is producing a product that will be exported to Europe. So the regulation states that we cannot feed the maggots with manure. It's just more of an idea or the library. It would be another project where the risks should be considered, specifically the biological risks. So I see that hen droppings or even for other types of manure or excretion, yes, it is well documented. The use of black soldier fly is appropriate to address or treat these environmental wastes, but this would have to be linked to a sterilization or disinfection process or project to make sure that at the end of the process there won't be any virus or bacteria or any type of microorganisms for the animals. But I have no practical experience in this regard because our company unfortunately does not use entropics. Perfect, thank you very much. We are getting many thank you messages for Dr. Rafael. Another question, what other types of insects do you use in the poultry industry? That's a shorter question. And the most complex question is when you refer to immunodualization of birds for the poultry industry, could you further expand on this concept? The two other types of insects that are more common are grasshoppers, crickets, that can have 70% protein, really high level of protein, and also the mealworm. This is the oldest one, used even for ornamental agriculture. But these other species are not well developed at an industrial level because the type of meal is different. This type of feed is dry and wheat-based, so it limits the environmental effect. And crickets. Crickets are more vegetable-like, so they're not as versatile. This is why in the market, 85% of industries are focused on the black soldier fly, because this is the most versatile insect and can be reproduced in 7 days. Whereas worm meal will take like 3 months to be harvested, so to speak, or to farm. And the other question regarding immunity is attached to kiting, that stimulates the immune system. Not only insect kiting, but also shrimp kiting, that it can have a stimulating effect in poultry farming. Also, since meals have an antimicrobial effect, they will positively change the microbiota in the gut, because it has certain enzymes, and the lauric acid, an antimicrobial agent. So this will provide for a less pathogenic microbiota. So this is the effect that could take place in immunity. Thank you very much. For Dr. Christoph, we have a question here, an open question in the chat. Do you consider that there could be a similar effect or behavior when using this type of vaccines in breeder and layer hens? And there is something that is in the question. For how long could this protection last?
So, yeah, I think I've got a similar question already earlier. So yes, definitely we can use it in layers and breeders. And yes, definitely we do believe that the same type of effect may be observed in this type of birds. In terms of duration of protection, we have demonstrated and published full protection against genotype 7 velogenic Newcastle challenge up to 72 weeks of age after only one application of the HVTF vaccine at day one. This was done in commercial layers, and this is published in the scientific literature. So we can provide you obviously with this paper.
Okay, para el Dr. Casaban nuevamente es Dr. Casaban.
Okay, for Dr. Casaban, once again, considering our tropical condition, do you consider that broiler hens or broiler chicken should include active vaccination in addition to recombinant? What is your position or your opinion?
So, in fact, we have to constantly adjust to the risk, to the epidemiological risk of Newcastle in a very quiet environment. And I would take the example of the United States or Brazil or Western Europe, where we know that for a very long time these areas are free of Newcastle disease. Then one single application of vector AVTF vaccine is enough and actually is implemented in the broiler industry. On the opposite, if we are in a highly endemic country, we can think about Mexico, we can think about Indonesia, among others, then it's definitely not enough. Why? Because the challenge is so high that it may hit the birds extremely early in life. And this HVT vector, like any HVT, needs approximately 3 to 4 weeks in order to reach its full potential. So in such a highly risky environment, we do advise to keep 1 or even 2 live vaccines, one a day old and another one, let's say, ideally anti-aerotropic apathogenic to be safe, and a second one based on Lasota at 8-10 days of age, just to cover this very early stage of the life of the bird. And after that, the HVTF will do the job. So you really have to adjust your program accordingly. If the situation cools down, as I mentioned before, you can step by step remove one live, and in another step remove all of the live vaccines, if really the situation is calm for quite some time. On the opposite, if it's getting hotter, or if you are surrounded by endemic countries, if you have a significant amount of backyard flocks, live bird markets, where we know that it's a significant reservoir of Newcastle disease, among other viruses, of course, then we have to keep on watching closely and keeping a few live vaccines on top of that. But again, according to the situation, it's enabling to have a kind of flexible vaccination program to be adjusted according to the actual pressure in the field.
Ok. Bueno, perfecto. En este
All
momento
right.
no te...
Thank you very much. At this moment, we don't have any other additional questions.
No, es la misma que ya acabo de
No,
leer.
this one that I just read is the one that you've just answered, Dr. Kazman. So we don't have any more questions in the chat.
De mi parte, quiero agradecer
So on my behalf, I'd like to thank Dr. Rafael and Dr. Christoph for your presentations and all the attendees also who participated and everyone who was involved
dándonos soporte de la parte técnica.
in the technical support for this session, both with the broadcasting of this session and the interpretation of the latter. So thank you very much. I'd like to give the floor to Cesar Pradilla so that he can conclude this event. Mauricio, thank you very much. And Dr. Hermes, Dr. Casaban, thank you very much for sharing with us this very, very relevant information and such updated information. And to all of you, our attendees, once again, thank you. Thank you for joining us in these very important spaces. And we'd like to invite you to continue joining us as we will be planning more events like this one. So remember that this conference, as all virtual conferences, will be available in our webpage as these are recorded. Please visit us at www.avemea.org. So on behalf of all our associate members and our steering committee, thank you very much, and we hope to see you very soon.
Gracias. Saludos. Tengan un buen día. Bye bye.
Have a good day. Bye.
Gracias. Dios.
Hasta luego, muchas gracias.
Hasta luego.